Good day, students, and welcome to part 2 on adding vectors using the parallelogram method. So we're going to be finding the resultant vector of a linear combination of two or more of these vectors, okay? So the instructions are to find the resultant vector geometrically using the parallelogram method, then verify the accuracy of your results arithmetically, okay? So let's go ahead and represent these vectors in coordinate form so that we can easily translate them into our new coordinate system. Okay, so let's go ahead and put the tail of the on each vector. So let's graph an origin on each tail so we can accurately determine what coordinates represent each vector. So there goes my origin on the tail of each vector. So for vector p, going from tail to tip, uh, for vector p, we go over 1, 2, 3, and up 1, 2, 3, 4, 5, 6. So 3, comma 6. For vector q, we go to the right 1, 2, 3, and up 1. So 3, comma 1. And then for vector r, we go to the right 1, 2, 3, 4, 5, 6, 7, and up 1. So 7, comma 1. And then for vector s, we go to the left 1, 2, 3, 4, and down 1, 2, negative 2. Okay? All right, now let's go ahead and try number 1. For number 1, we're going to find the resultant vector of negative 1/3 p, negative 1/3 of vector p minus 3/2 of vector s. Okay? All right, these two vectors are negative. We're going to be adding them, so we need to take the opposite of each independent vector so we can add them, okay? So what are we graphing here? We're going to be graphing negative 1/3 p and negative 3/2 s. All right, so let's start with the first one. Negative 1/3 p is what you get when you distribute negative 1/3 to vector p, okay? So negative 1/3 times vector p, which is 3, comma 6. So if you distribute negative 1/3 in there, you are going to have negative 1/3 times 3 over 1 for the x coordinate after distributing negative 1/3 to the x coordinate, and then you're going to distribute negative 1/3 to the y coordinate, and that's going to yield negative 1/3 times 6 over 1. Okay, so you have it like that. All right, let's go ahead and simplify that. That becomes, these 3's cancel out. So for the x coordinate of negative 1/3 p is negative 1. And then in this case, 3 goes, this is a different color. 3 goes here once, and then 3 goes here twice. Negative 1 times 2 is negative 2. So we have negative 1, negative 2 as negative 1/3 of vector p. Okay? All right, now next thing we're looking for is negative 3/2 s. So negative of 3/2 of vector s is what we get when we distribute negative 3/2 to vector s, and vector s is negative 4, negative 2. Okay, so let's go ahead and do the distribution. So when we distribute negative 3/2 to these two, we're going to have the vector negative 3/2 times negative 4 over 1 for the x coordinate, and then negative 3/2 times negative 2 over 1 for the y coordinate. Okay? All right, now we're going to cross reduce. 2 goes here once, 2 goes here twice, and if we multiply those two, negative 2 and negative 3, we end up with negative 6, actually positive 6, because minus times minus is plus for the x coordinate. For the y coordinates, 2 goes here 1, 2 goes here 1. Negative 3 times negative 1 is positive 3. So we have 6, 3. 6, comma 3 is the vector for negative 3/2 s. Okay? All right, now we're good to graph. So let's start off by graphing vector p. Let's examine the vectors first. Vector p, negative 1/3 p, goes in the third quadrant. It goes to the left 1, and then it goes down twice, so it's not too big. But if we look at vector negative 3/2 s, we're going to go to the right 6 and up 3. So if we centralize our coordinate system, that should be able to accommodate the two vectors. All right, so let's centralize it a little bit, and then something like this should work. All right, now we're going to graph these two vectors on this coordinate system. Let's start off by graphing negative 1/3 p, okay? So negative 1/3 p is start from the center, 1 unit to the left, and 2 units down, 1, 2. All right, so there goes the tip of vector or negative 1/3 p. All right, so let's go ahead and graph that. There to there. All right, and then let's go ahead and graph, let's label it first so we don't get confused. This is negative 1/3 of vector p. All right, let's go ahead and graph the next one, 6, 3 for negative 3/2 vector s. So we're going to go to the right, 1, 2, 3, 4, 5, 6, and we're going to go up 1, 2, 3. Okay, so there goes the tip for vector s. Let's go ahead and draw that. Let me change the color to blue. All right, so I'm going to graph it. And there goes vector negative 3/2 s. Let's go ahead and label that. So this is vector negative 3/2 s. All right, so now what we're going to do is we are going to try and create a parallelogram, all right, using these two vectors, and then the diagonal will be the resultant vector. So how do we go about creating this parallelogram? Now what we'll do, we're going to translate vector negative 1/3 p to the tip of vector negative 3/2 s. So that means we're going to go use this direction. From the tip here, we're going to go down 1. Actually, we're going to go to the left 1, since that's the x, go to the left 1 and down 1, 2. All right? So to left 1 and down 1, 2. Let's use a dotted line, since this is the translation of vector negative 1/3 p. Use a dotted line like that. And then if we connect the dots, these two tips right here, that should be the translation of vector negative 3/2 s onto the tip of vector negative 1/3 p. So connect it like this, and there goes our parallelogram. All right. So the resultant is always the vector you get when you draw from the origin to where the two translated tips meet. Okay. So let's go ahead and draw our resultant vector. Let's make it red. So our resultant vector is going to be a solid line, okay, from here to here, and that's our resultant vector right there. Okay. All right, so let's go ahead and label it, see what the coordinates of the tip is, and then see if it's in fact correct. So this vector right here is negative 1/3 p minus 3/2 s, and the coordinates are, we go to the right, 1, 2, 3, 4, 5, and up 1. So it's 5, 1. So the question is our answer correct? Now let's do the numerical verification by doing it using the numeric method. So numerical method. All right, so we already have the vector scaled and reflected, so we just basically combine our results that we got here to get the answer, all right? All right, so for the numerical method, we have negative 1/3 of vector p equals negative 1 comma negative 2, and then negative 3/2, let's bring this down a little bit, negative 3/2 s is 6 comma 3. So what we just do is we just add these two reflected and scaled vectors. We just add them up. All right, and then our final result, if we add them up, is going to be minus 1 plus 6 is positive 5, and then minus 2 plus 3 is just 1. So this is negative 1/3 vector p plus negative 3/2 of vector s. All right, equals this. Is this what we had here? That's absolutely what we had, so we're confident that our answer is in fact correct. Okay, so that's that. All right, let's move on to number 2. All right, so for number 2, we're going to be looking for vector P plus Q minus R. Okay, so we're going to be combining 3 vectors this time. So to do this, we just simply need to do 2 at a time. We resolve 2 and then resolve the resultant of that with the third vector, okay? So let's write down what the coordinates of these vectors are. We know that vector P is 3, 6. Vector Q is 3, 1. Since we're graphing negative r, we have to distribute that negative to vector r. So negative r is going to be negative of the coordinates of vector r, which is 7, 1. And then if we distribute that minus to these two numbers, distribute the negative to the 7 and the 1, the negative r is basically going to be negative 7, negative 1. All right, so that's that. Okay, so what we're going to do first is let's do p plus r, and then we're going to combine that with, we'll do p plus q, and then we'll combine that with negative r, all right? So let's take a look at these two. These two vectors are in the first quadrant. This one goes as high as 6, to the right 3, and then this is clearly in the third quadrant, but it goes way to the left 7 units, okay? So what we're going to do is we're going to centralize our coordinate system. Put it in the center, like this. And then lift, this goes as low as negative 1, this goes as high as 6. So the y coordinate goes higher here. The positive is bigger, so we shift our y coordinate downwards a little bit, okay? Okay, now let's go ahead and graph p plus q. All right, so vector p, you go up 3 and over 6. So go up 3, 1, 2, 3. We'll go to the right 3, 1, 2, 3, and up 6, 1, 2, 3, 4, 5, 6. So that's vector P. And what we're going to graph next is vector Q. So let's label this vector P. All right, now we're going to graph vector Q. Vector Q will go to the right 3 and up 1, 1, 2, 3, and up 1. Let's draw vector Q. I'm going to use color blue this time. So this is vector Q. So let's label it so we don't get confused, vector Q. All right, so now what we're going to do next is create our parallelogram using by translating one vector to the tip of the other vector and then constructing the parallelogram, okay? So vector Q, I want to graph vector Q on the top of vector P, okay? So vector Q is up 1 over 3. So let's do that same thing on vector P. So for vector P, we're going to go up 1 over 1, 2, 3. So there goes the tip of vector Q. All right, so let's go ahead and draw vector Q again. So we're going to draw it right here. Let's make it a dotted line this time, since it's not the actual vector, it's just a translation. All right, so there goes vector Q. Okay, now let's finish this up by completing the parallelogram, connecting these two vectors together. So there goes our parallelogram. Now the diagonal starting from the origin to where the tips of the translated vectors meet is going to be the sum of the two vectors. Okay, so let's go ahead and draw that. I'm going to draw that in red. So this vector right here, make sure I have the right color. So this vector right here is vector P plus Q. Okay, let's go ahead and label it. This is vector P plus Q. Okay, all right, now is that what we're looking for? Absolutely not. We just added the first two. Now we need to combine it with negative r. Okay, so where is negative r? Let's go ahead and graph negative r. Negative r is negative 7 units to the left. Let's do that in green. Negative 7 to the left. 1, 2, 3, 4, 5, 6, 7, and down 1. Okay, so there's the tip of vector r. Let's go ahead and graph it. Vector r. let's make it green. All right, so vector R goes from the origin and points all the way there. All right, so there goes vector R. All right, let's label it so we don't get confused. There's a tip, and then this right here is vector R. I'm sorry, negative R. Okay? Okay, now we have negative R and P plus Q. We're just going to combine the green vector and the red vector, and that will give us our resultant, okay? So how about we just copy the red vector onto the tip of the green vector, okay? Or better yet, how about we copy the green vector onto the tip of that, since we already know what the green vector is. All right, so let's go ahead and do that. So the directions of the green vector are to go to the left 7 and down 1. So let's do that. So starting from the tip of the resultant from adding P and Q, which is P plus Q, we're going to go to the left 7, 1, 2, 3, 4, 5, 6, 7, and down 1. Okay? All right, so that is the translation of vector R onto the tip of P plus R. So let's make that green, connect it like that. Okay? All right, now we're going to create a parallelogram by connecting these two diagonals right here. So let's go ahead and construct the translation of P plus Q. This is going to be red. Let's make sure they match. So we just connect these two right here. So we have our parallelogram. Okay, so this is the parallelogram we're looking at. So the diagonal of the green vector R and the red vector P plus Q, that parallelogram constructed by these two, the diagonal starting from the origin will be your final answer. Okay, so let's go ahead and draw the final answer. Let's make that in black. Okay. Alright, so let's draw it with the black arrow. And this is the final result that we're looking for right here, this vector. Okay, so that black vector we just drew is the resultant of the combination of the three vectors. So this vector right here is vector P plus Q minus R. And the coordinates are, what are the coordinates? You go to the left one and up 1, 2, 3, 4, 5, 6. So -1, 6. Okay, now let's go ahead and combine these three vectors and see if we get the same result. Okay, so we're going to do this using the numeric method. So numeric method. All right, so for the numeric method we have P. We know P is 3, 6, and then Q. Let's add those two first. Is 3, 1. So we can even add negative R. Just do everything at once. So -7, -1. All right. So since they're all lined up, we can just combine them straight down. Okay. So for the vector P, let's do the x-coordinate first. So for the x-coordinate, 3 plus 3 is 6. 6 minus 7 is -1. And then for the y-coordinate, 6 plus 1 is 7. 7 minus 1 is 6. So this vector we have right here is vector P plus Q minus R. And it matches the answer we have here. So our answer is correct. And we're confident that our result is correct also. All right? So that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. More clips can be found on MathLearnServe.com, and you can please post a comment to tell me what you think about this clip, and you can like this video if you liked it. Okay? Thanks again, and have a wonderful day.